This is just a really quick overview of right triangles and using Pythagorean Theorem, just sort of a review. So say, triangle with your three sides, your three angles. If you look specifically at a right triangle, it has one right angle. The other two angles are going to be acute. Remember, those are ones that are less than 90 degrees. So both of these are acute. It does have three sides, but it has three special sides. The side across from the right angle is called the hypotenuse. It's always the longest side in a right triangle. Then the other two sides here, labeled lowercase a and lowercase b, those are legs. And it really doesn't matter which one you call a or b, as long as little b is across from angle b and little a is across from angle a. Okay, so you have that, the two legs a and b, the hypotenuse of c. Then if you'd like to find missing side lengths, given that you have two, you have the Pythagorean theorem. And you'll plug in the values that you have, you'll square them, you'll solve for the missing side. Sometimes you give it exact, sometimes you can give a decimal. For example, you have a triangle where one leg is 3, the other leg is 4, and you need to find the third one. So the 3 and 4 are legs, so it doesn't really matter which one you make A and which one you make B, as long as you keep them on the same, the correct side of the equation. So you'll take your a squared plus b squared equals c squared. You'll plug in your 3 and square it, plug in the 4 and square it. You get 9 plus 16. Add those together to get 25. And then you'll square root both sides to get the c value is exactly 5. And because we're doing side length application for a triangle, there's not a need to plus and minus the answer here, because you can't have a side length of -5. So you always pull the positive answer whenever you're using Pythagorean theorem on right triangles. But so sometimes the answer is a nice integer whole number. Those are special triangles. The sets of numbers are called Pythagorean triples. But a lot of the times you'll have the triangle where, it's not exactly so nice and integer based. So, if this is say this side is 8 and the other leg is 12, and you want to find the hypotenuse. Again, you're applying Pythagorean theorem. A squared plus b squared equals c squared. If all you have are side lengths, then you square 8, you square 12. 8 squared is 64, 12 squared is 144. You add those two together, you get 208. And then if you square root both sides, you get that c is the square root of 208, which is decimal around 14.42, but you'll want to try to keep the exact answer, because the square root, you round the decimal, it changes the answer. In the event, and these are not drawn to scale, in the event that you are given the hypotenuse and say one of the legs were, we'll go with 9, and you need to find the missing leg. Again, it doesn't matter if you want to call it A or you want to call it B. It's really up to you. Make that A, make that B. It's always C. What matters is when you go to plug in your information, that the measure of the hypotenuse makes it into the c squared place. You don't just square them and add them together, take the square root. It matters if you need a leg or if you need a hypotenuse. So if I square 9 and then I square my hypotenuse, I get 81 plus my missing side squared equals 400. Now I'll subtract, instead of adding them together, I'll subtract the 81 and get x squared equals 319, and so x is the square root of 319, which is, approximately 17.86. It should be less than 20 because 20 is the longest leg, or the longest side in a hypotenuse in a right triangle. So less than 20, we're good with that. And again, the square root of 319 is exact, and the 17.86 is approximate. So you need to try to make sure you can give exact and leave it that way for doing Pythagorean theorem. But again, it has nothing to do with the measurement of either of those other two angles. It just has to deal with how you set up the leg and the hypotenuse relationship and trying to find for the missing side lengths.